In this example, we want to find a second degree Taylor polynomial centered at pi over 3 for the function f of x equal to cotangent of x. And this is called an nth degree Taylor polynomial. And so we want a second degree, and then we will stop with this term. If we want a third degree polynomial, then we would stop with this term, and so on. And so what we need to find is this polynomial right here. Since we want a second degree polynomial, we stop with the second derivative. And so the function here is f of x equal to cotangent of x. And then now we need f of c and this will be f of pi over 3. This is cotangent pi over 3. And this is 1 divided by the square root of 3. And then next we need the first derivative. And the derivative of cotangent of x is negative cosecant squared. And then we need the first derivative at c. So this would be pi over 3. And this would be negative cosecant of pi over 3. And squared. And this will be negative 4/3. And then next we need the second derivative. So we have to use the chain rule right here. So this is cosecant to the second, so the derivative will be negative 2, that's 2 for the exponent, and then times the base, which is cosecant of x. And then by the chain rule, we have to find the derivative of the base cosecant, and the derivative of cosecant is negative cosecant times cotangent. And so here we have negative times negative is positive, so we get 2. And then cosecant times cosecant, that will be cosecant squared. And then times cotangent of x. And then now we need the second derivative at c. And then c is pi over 3. So in the place of x here, we put pi over 3. And then this comes out to be 8. Divided by the square root of 3, and then to the third. So now that we got f prime of c and we got second derivative at c, we're ready to form the second degree Taylor polynomial here. So f of c is 1 divided by the square root of 3, and then plus, and f prime of c is negative 4/3, and then we need the x minus c, that c is pi over 3, and then plus this. Second derivative at c is 8 divided by this. And this is x minus pi over 3. And then 2 factorial is just 2. And this is called a second degree Taylor polynomial, corresponding to the function f of x equal to cotangent of x. And so now let's look at the graphs of f of x, the function f of x equal to cotangent of x, and the graph of the second degree polynomial. And then we will see that they are very similar, that they will overlap for values around pi over 3. So this is the graph of cotangent of x and the second degree polynomial. That should be a 2 right here, because this is not a first degree polynomial, but it should be a second degree polynomial. And so, and then this is pi over 3 right here. And then if we look at the two graphs, they overlap at values near pi over 3. So the graphs overlaps from here to here. And so that's what Taylor polynomial does. It approximates functions